Hi there. And what we're going to do is look at another limit that involves an indeterminate form. And we're going to try to rearrange this particular one and try to use L'Hopital's rule to evaluate the limit. So let's see what we come up with here. So we have the limit as x approaches infinity of x times sine of 1 over x. So it's a product of two things. So as x goes to infinity, the first term goes to infinity, the first factor goes to infinity. The sine, however, it's sine of 1 over huge, which basically is sine of 0, which is 0. So this is a limit of the form infinity times 0. Now remember our strategy. The strategy is we write it as a fraction where we take the reciprocal of one of the factors. So it's either the reciprocal of x in the denominator or it's the reciprocal of sine of 1 over x in the denominator. I think it's going to be the reciprocal of x in the denominator. So we have the limit as x approaches infinity of sine of 1 over x divided by 1 over x. And just to double check, this is going to 0 and 1 over x is going to 0. So we're good to go in using L'Hopital's rule. So L'Hopital's rule says, take the derivative of the numerator, take the derivative of the denominator. And just a little fun fact here, if we want the derivative of 1 over x, which remember is the derivative of x to the negative 1, that is negative 1x to the negative 2, which is negative 1 over x squared. That is one of those derivatives that we just happen to see often enough. It might be worth memorizing, going from 1 over x directly to negative 1 over x squared. So when we apply L'Hopital's rule here, the derivative sine of 1 over x is the cosine of the something times the derivative of the inside. And then the derivative of the denominator is negative 1 over x squared. And that's actually really good news because the same thing showed up in the numerator and denominator. Those essentially cross out, which means we have the limit as x approaches infinity of cosine 1 over x. But as x goes to infinity, this goes to 0. So this ends up being cosine of 0, which is 1. So that original limit is 1. And that we get by L'Hopital's rule.